Hello friends, welcome to the course Essentials of Data Science with R Software 1, in which we are trying to understand the basic fundamentals of probability theory and statistical inference that are useful for data science. Okay, so now you can recall that in the last lecture we started a discussion and we developed test statistics that can be used for testing the hypothesis related to the mean of a normal population. And in that case, we had assumed that sigma square is known. Now, the next question is what to do if sigma square is unknown, and actually in practice if you try to see sigma square is unknown to us. So, the most simple option is that we can estimate it on the basis of a given sample of data, and we can replace it in the place of sigma square and try to develop a statistic which can be used for testing of hypothesis related to the mean. Well, in the last lecture I had given you the developments in detail, means how the critical regions are located, how the decisions are taken on the basis of critical region and the nature of hypothesis, whether it is left tail test, right tail test or two tail test. So, in this lecture I will not be giving you that much detail, because the steps, procedure, everything is the same. The only thing is this: you need to know basically the statistic and how to get it done in the R software. But before going into the lecture, one thing I would like to address you that is very important to understand. There are two topics which we have done. One is estimation of the parameters and another is testing of hypothesis that we are doing. Remember one thing, the topics which we have done in the estimation of parameter, they are helpful in finding out the good value of the unknown parameter that is existing in the population. Now, in the case of testing of hypothesis, we are only trying to compare. Suppose the null hypothesis that h naught mu equal to 8 is not accepted, then the question comes, well, mu equal to 8 is not true, that means mu is not equal to 8, but what is the correct value of mu? That cannot be answered from the tools of test of hypothesis. These tools can only help you in making a comparison with a hypothetical value, or comparison between two samples, or comparison between more than two samples. So, this is very important point that you have to keep in mind. Okay, so let us now begin our lecture, and I hope that you had a revision of the last lecture, because it is very important to understand the topics in this lecture and in the next lecture. Okay, so let us begin our lecture. Okay, so now we are going to understand the test for h naught mu is equal to mu naught, right, and where we are trying to assume that sigma square is unknown. So, this test essentially is in a common language, this is called as a t test, because you will see that this is based on the t statistics. And similarly, when sigma square was known to us, then we had used the statistics z is equal to x bar minus mu upon sigma by root n, right. So, since this is based on the z statistics, so many times people in common language they call it as a z test or Gauss test, right. So, these are the different names, so you do not get confused. I mean, if you are trying to listen these names instead of the test procedures. So, in this case we assume that let x1, x2, xn be a random sample of size n from normal mu sigma square, and we assume that sigma is unknown, population is normal, and sample size is small. What is the meaning of small? N less than equal to 30. Now, I do not need to explain you why this condition is coming, because you can recall that we had discussed that when the degrees of freedom of the t distributions are 30 or more than 30, then the normal distribution become the same, means their structure become the same, their probabilities become the same. Okay. Now, in this case we use the test statistics which is given by here like this, TC x bar minus mu divided by S by root n. So, what we try to do, because sigma square is unknown, so we try to estimate the sigma square by S square, right, and this is S square is an unbiased estimator of the sigma square. So, we try to replace sigma square by S square and we have this statistics. Now, the question comes how this statistics is coming. Well, it is not coming from sky, but this has been derived using the Neyman-Pearson lemma, which is briefly called as NP lemma, or this can also be derived using the likelihood ratio test, right. So, do not think that it is coming from sky or well, if you wish you can just find out the likelihood function under H0, under H1 and then try to take the ratio, try to solve them, try to find out the critical region, and you will come to know that this is the statistics. Now, what we have to do? We have to get the sample and we have to compute the value of this TC on the basis of given sample of data. Now, how to compare it? So, for the comparison we can fix the value of alpha, that is the level of significance, to be say 5%, 1% or anything whatever you want depending on the requirement. And then we try to find out the probability distribution of this statistic TC, and then we can find that TC has got a T distribution with n minus 1 degrees of freedom, right. And you remember that when we had done the T distribution also, then also we had discussed this topic, that the distribution of such a statistics is T distribution. Okay, now the critical values of this T distribution can be obtained from the T tables for a given degrees of freedom and value of alpha, and in case if degrees of freedoms are more than 30, then instead of finding out the T values, one can use the critical values from the standard normal distribution. There is no issue. And yeah, in case if you are trying to do it on the software, then there is no issue, you can simply compute the P value. Okay, now as we did earlier, in case if you want to test our hypothesis like H1 mu is not equal to mu naught, that means we have a two-tailed test, then the critical regions are going to be on the both the sides of the distribution. This curve is the distribution of T distribution with n minus 1 degrees of freedom. So, this region is going to be alpha by 2, this region is going to be alpha by 2, and these are the critical values at alpha by 2 level of significance that can be obtained from the table or from the software, right. And so, these are the things. So, you can see here, this is the region here which is 1 minus alpha, right, this region exactly on the same way as we have done earlier. And in this case, what are you going to do? If you want to accept or reject a hypothesis in a very simple language, you are simply trying to do the same thing that we did earlier, that you try to compute TC and then try to see where this TC is going to be in this graph, here in the critical region or here in the acceptance region. So, wherever this TC is there, you try to accept or reject the hypothesis. For example, if TC is lying between minus T alpha by 2 and T alpha by 2, then we accept it. And if TC is greater than T alpha by 2 or it is smaller than minus T alpha by 2, then we are going to reject it, as simple as that, and this is what precisely I have written here. So, if you try to understand it from the graphic point of view, I personally feel that it becomes very easy to understand. Okay. Now, similarly, in the case of H1 mu is greater than mu naught, that is a right tail test, the critical region is going to be on the right hand side, compute the value of TC and try to see where it is lying. So, this is your here acceptance region and this is your here critical region, and try to see where the capital TC value or the calculated value of the T statistics is going to lie. If this is lying here in the acceptance region, accept the hypothesis. If it is lying in the critical region, try to reject the hypothesis, right. And similarly for the left tail test also, the critical region is going to be on the left hand side. Just try to find out the calculated value of the statistics and try to see whether it is lying in the critical region or in the acceptance region, and then based on that you try to accept or reject the null hypothesis. Whenever we are talking of the accepting of or rejecting a hypothesis, and I am not saying any name like alternative or null, then the null hypothesis is the default, right. We say accept the hypothesis, reject the hypothesis, that means we are referring to H0, right. That is our understanding. So, Now, in case if you want to do the test of hypothesis on the basis of p value, so you do not have to do anything, the software will compute it and then you have to just look into the value of p and then you have to take a call whether you are going to accept or reject the hypothesis, right. So, in this case for two tail tests the p value is defined like this, for right tail test like this and for left tail test like this one. So, that is simple straightforward, and H naught is rejected at 100 alpha % level of significance if p value is smaller than alpha. This is what you have to just keep in mind, as simple as that. Now, the next question comes, how are you going to do or conduct such a test of hypothesis in the R software. So, for that this procedure is built in the base package of R. You do not need to employ or install any additional package for this, as this was the case in the case of when sigma square is known, right. So, the command here is t.test and this performs one sample, two sample t-test for different type of conditions. So, here I am trying to first give you the details, but we are going to use here the details only for this test, and remaining details you will see we will be using in the next lecture when we try to consider the test of hypothesis for two samples. Okay. So, now the command here is simply here t-test. So, the more simple is this, you simply try to write down here t.test all in small alphabets, lowercase alphabets, and give here the data vector x. But in general, if you try to look into the help, this will give you this type of command, and where I am trying to explain you now each and everything, and later on we will use it. So, command here is t.test, x is the data vector, y is the data vector for the second sample, but at this moment we are not considering the second sample, we are doing only the one sample t-test. So, that is why I am writing here as a null, and you double it in the capital letters, and then I have to specify the alternative hypothesis H1. So, for that I have three choices, two sided or less or greater. So, I have to choose any one of them, and I simply have to write down within the double quotes the value like as 2 dots sided or less or greater depending on the requirement. Mu here, it is the value of here H naught mu equal to mu naught. So, this is the value of here mu naught. So, by default it is taken to be 0, but you can give here any value. Now, the next option here is PAIRED, paired. So, paired is related to when we are trying to do the two sample paired t-test. That means, when the observations are paired. So, that is why this is a logical variable, it can take value true or false. So, whenever you are trying to conduct the two sample pair t-test, then this value will simply become true, that is all. And now, there is another option here var.equal, that is variance equal. Well, this is also valid for two sample test that we are going to discuss in the next lecture. So, when you are trying to take the two sample test, then you have two samples which are coming from normal population, and there can be two situations whether the variances of the normal population are the same or they are different. So, based on that you have to specify here whether the variances are equal or not in terms of true or false. So, if here in the present case, since I am dealing only with the one sample test, so I will put it here as a false. Now, this is here confidence level, that means the value of 1 minus alpha. Remember one thing, this is the value of here 1 minus alpha. So, this is given by CONF.LEVEL, and here you have to specify the value. So, for example, here I am writing 0.95, and after that there are many other options. I will simply ask you to look into the help, that will give you more details. So, now today I have explained you the use of this command, and the same command we are going to use when we are trying to consider the two sample test. Okay, but there I will simply refer you that there we had discussed, and you have to remember these things. Okay, so now here I have given the details what I just explained you, that x and y are the data vectors, alternatives is the specification for the alternative hypothesis. This can be two sided, greater or less. Two sided means H1 is mu not equal to mu naught, greater means H1 is mu greater than mu naught, and less means H1 mu less than mu naught, and mu here is the value of mu naught. Right, that is as simple as that. And simply I have given you here the option for paired, that is for the 2 sample paired t-test, and variance dot equal VAR dot equal, that means the variances are equal or not, and confidence level, this is the value of 1 minus alpha. So now using these options you can conduct any sort of test of hypothesis. So let me try to take here the same example that I considered earlier. Well, you can ask me why I am considering the same example again and again, and I am just modifying smaller things. My idea is very simple, that I want to give you a feeling that what will happen when, under what type of conditions, what are the statistical changes that can occur in the data and the related outcomes. So now you have considered here the same example in different situations. So now you can compare the outcomes when, for example, sigma square is known, sigma square is unknown, you are trying to change the level of significance, when you are trying to construct the confidence interval, etc. So this will give you a complete analysis, or you can consider that many times people ask for a case study. So now in this case study I have taken the same data set and I have employed all possible tools. Right. Okay. So now in this example we have the data of 20 temperature of the day, means weather temperature in a city, and that is assumed to follow a normal mu sigma square distribution, where sigma square is now unknown. Earlier we had taken it to be known. So now this data is here like this, which has been stored in a variable temp. So now we try to use here the command on the R software, and we try to solve the same example. Right. So suppose we are interested in testing the hypothesis H1 mu is not equal to 40 degrees Celsius. So now how to input this data, how to read the command, how to give the instructions to the command, and how to read the different outcomes of the software. That is what we have to understand here, and here I am going to explain in detail, and after that in all other cases I will simply follow the same rule. So you see here, in order to test this hypothesis, first we take a call that which of the test we have to use. So because here sigma square is unknown to us, so we decide for the t test. So the command will become here t dot test, and now we try to give the input data, which is here in the data vector temp, that is temperature. Then the second data vector is going to be null, because we are considering here only the one sample t test. Then the alternative has to be specified based on this H1 mu is not equal to 40, which is here 2 dot sided. Right. Now you have to specify here the value of mu, which is here the value of mu naught, which is equal to here 40. Now you will say here paired is equal to false, because you are not considering here 2 sample, and then variance dot equal to false, because you are again considering only the one sample test, and confidence level, that is conf dot level, that is equal to 0.95. And if you try to see here, this is the outcome that you will get in the R console. So now you have to understand what this software is trying to explain you. So the first line here is the name of the test, which is one sample t test, and then what data you have used, that is temp. Now here it is giving the value of here t. So t is the value of here Tc, which was x bar minus mu naught, which is actually here 40 divided by s by root 10. So and here is 20, right. So now this value is computed. For that sigma square is estimated by s square, it is replaced, and then this quantity comes out to be 1.4476. Now this is here df. Df means degrees of freedom. So this is n minus 1. So this is 20 minus 1, which is 19. Now this is the value of here p, that is p value is coming out to be 0.164, that is computed by the software, and then it is indicating that what is the alternative hypothesis, that the true means is not equal to 40, right. So looking at the software outcome also, you can know that which of the hypothesis is being tested here. Then you see here it is also giving you the 95% confidence interval, which is between 39.12384 to 44.80616. right, and sample estimate for the mu, that is here arithmetic mean of x is coming out to be 41.965. Now I ask you to think, what is this thing? Do you remember that when we had learned the confidence interval for mean when sigma square is unknown, then we had used the statistics x bar minus mu divided by s by root n to calculate that this value is lying between minus Tn minus 1 to Tn minus 1, and then we had computed our confidence interval. And in that situation, when I was trying to explain you how to obtain the confidence interval on the basis of our software, then I had given you an example, and this is the same example which I am considering here. And I had told you that if you want to obtain the confidence interval, you have to use the command here like t dot test, and then you have to give here a dollar command, and then you have to write down here conf dot int and so on. So at that moment, if you try to see and if you try to recall, I had explained you that at this moment I am trying to give you only the statement, but why this statement is coming, how this statement is coming, that I will be in a condition to explain you later on. So this is the place where I can explain you that you can remember that in the first lecture on the test of hypothesis, we had considered that test of hypothesis and confidence interval estimation, they are also interrelated, and looking into the value of confidence interval, you can also take a call whether your null hypothesis is going to be accepted or rejected. So that is why in this software, this is also giving you the value of confidence interval. So since you are giving here confidence dot level is equal to 0.95, so this is giving you here the 95% confidence interval. Now you can see whether this value of h naught mu equal to 40 is lying inside this interval or not. So you can see here the lower limit of the confidence interval is around 39.12 and upper limit is here 44.80, and your this h naught mu equal to 40 is saying that mu here is like 40, right. So you can see here this value h naught mu equal to 40 is going to be lie in this interval, and when this value is lie in this interval, then we say that the h naught is accepted, right. So in this case you can accept, yes, the temperature in the population is close to 40 degree, and this is the same thing which you can observe here also. The p value is coming out to be 0.164. So p value is greater than value of alpha, alpha is equal to here 0.05. So you can see here that the rule was reject h naught when p is less than alpha, right. So now you can see here that p is greater than alpha, so we are going to accept the hypothesis, and the same conclusion that you can draw on the basis of p value, that is also drawn on the basis of confidence interval. So this is what I wanted to explain you, right. So I hope I am clear here. One thing you have to keep in mind, that whenever you are trying to work in the software, you have to understand what you need to specify, whether you need to specify the value of alpha, level of significance, or you need to specify 1 minus alpha, which is the confidence coefficient. So that is obtainable. This information can be known only after looking into the instructions and help menu of the software for that test. So for example, in the case of this t test, you have to specify the value of here 1 minus alpha. So in case if you decide that alpha is equal to 0.05, then you have to specify here 1 minus 0.05, which is 0.95. Okay, so I hope I have made everything clear in this software outcome, and I have explained you how are you going to take the outcome. Now in the next cases, this will go very simply straightforward. So this is here the screenshot of the same test which I shown you. Anyway, I will show you on the R console also. Now in case if you try to change your alternative, that h1 becomes mu less than 40, then the entire command, everything remains the same. Only thing becomes here that alternative is going to be changed. Now alternative becomes inside the double quotes you have to write less, and then you have here this outcome, and this outcome can exactly be seen in the same way as we have done earlier. But you can see here that 95% confidence interval is coming out to be like here minus infinity to 44.3122. So this is INF means infinity. So this is the interval minus infinity to 44.3122. And if you recall that in the case of confidence interval estimation, We have done two-sided confidence interval, one-sided confidence interval. So, this is your here one-sided confidence interval, and if you can recall, we had obtained that the value is going to be start from minus infinity to the point or from the point to infinity. So, in this case, when you are trying to consider the alternative hypothesis like h1 mu is less than 40, then you are going to have an interval like this one. And again, you can take the conclusion through the use of p value, or you can also take the same conclusion from the confidence interval also. And this is the screenshot. This I will try to show you on the R console, and this is the last step hypothesis that h1 is mu is greater than 40. So, in this case, you simply have to use the same command. Alternative is going to be now greater. So, now if you try to execute this command, this is here the outcome, and you can see here the outcome is exactly the same as earlier, only the p value is going to be changed, right. And you can see here the confidence interval is also now changing. The confidence interval is now becoming from 39.6178 to infinity. So, this is a one-sided confidence interval, and that is the same thing that you learned when you did the confidence interval estimation, right. So, now you can see here that everything is now clear. How are we going to consider the test of hypothesis? How are we going to implement it? How are we going to interpret it? And the interpretation can be made on the basis of p value or on the basis of confidence intervals. You will see that in some of the test of hypothesis in the outcome, sometime you will get the confidence interval, sometime you will not get the outcome containing the confidence interval. So, but now you know whatever you want to do, you can do it very easily, right. Okay. And this is here the screenshot of the same thing, but now let me try to first come on the R console and try to show you that whether these things are really working or not. Okay. So, first let me try to copy here the data here temp temperature. So, you can see here this is the data here temp, and now you have to simply use the command here for the t-test. So, for the two-sided t-test, you can see here this is here the outcome, and in case if you want to make it here unsided test, say here less than type. So, this is the alternative LESS has to be changed, and you can see here this is here the outcome for the h naught mu less than 40. And in case if you want to do it for the greater than, then you have to simply give here the command in which you have to change the alternative to be only here greater. So, you can see here this is greater and the outcome here is like this. So, you can see here that everything is going to be changed, and in case if you try to change here the, suppose if I try to change here the confidence level to suppose here 50, that I am saying that okay, the type 1 error is going to be 50%. Well, it is not acceptable, but still I want to show you something, that is why I am doing it here. You can see here this confidence interval. This is in the first case when your confidence level is 95%, it is 39.6178 to infinity. But if you try to increase it to 50%, this is also changing from 41.965 to infinity, right. So, and similarly if you can see here for say alpha equal to 0.05 and 0.5, the p values are going to remain the same. Why? Because p values are sample dependent. In this case, if you try to look the values from the table, means for example, if you are trying to do this calculation using the calculated values and tabulated values from the t table, then if you try to change the value of alpha, this tabulated values are going to change, and then your decision may change. But that is the advantage actually of using the p value. And once you are trying to use the p value, these are the sample dependent value and the software is computing them. So, that is why whatever you alpha you want to choose, this p value is not going to change, but your decision will change, because your rule was reject h naught when p value is less than alpha. So, either you are trying to compare the p value with 5% or 50%, that is your choice. Okay, so, this is how we are going to conduct the test of hypothesis. One point I would like to emphasize towards the end of this lecture, that many times you will read a different type of literature, that there is a discussion whether this p value should be used or p values are dependable, etc., etc. So, definitely I am not going into that discussion. My job is to make you learn, and I have given you both the approaches. If you are trying to compute the calculated value of t statistics, you are trying to find out the tabulated value of the t statistics from the probabilities of t table, or you are trying to use the software to compute the p values, right? You should know both the things. Definitely the first approach has no issues. Everybody believes on it, that if you try to find out the value of t statistics on the sample of data, and then you try to find out the tabulated value from the t table, and if you try to take a decision, means everybody will agree without any discussion, without any confusion, right? But I wanted that you should know this thing, that because in data sciences you are trying to do all those things in an automated way, right? And these types of things are very popular in data science, and particularly when you are trying to do the different types of statistical modeling. These tests of hypotheses are the backbone of the statistical modeling. Without them, I can guarantee you, you cannot do any type of modeling, including the linear regression modeling. And that was the reason I had chosen the topic of this course to be essentials of data science. After this, whether you want to do data science or not, that is up to you, but without them you cannot do it. That is the guarantee. Right. So, I will stop now in this lecture. I will try to request you that you please try to look into assignment, your books, try to get some more example, and then I will try to take up the issue of testing of say mean in some other condition in the next lecture. So, I will try to see you in the next lecture, and till then, goodbye.